as you know, we dark sky advocates rely very much on the scientific information that comes out of numerous research groups around the world who are studying the effects of light on humans and the natural world. And it is a crucial component of our advocacy work. We very often, for example, quote the work showing the link between light pollution and rates of cancer. One of the most important of those studies comes from, next door to where we are right now, Harvard Medical School. And the leader of much of the work that comes out of Harvard Medical School related to the effects of artificial light on circadian rhythms, the daily 24-hour cycle of humans, is our guest speaker today, Dr. Charles Czeisler. Chuck, thank you very much for coming today and helping us understand some more of the science behind the issues that we care so much about. So, welcome.
Just to put this in perspective, when I started doing research on sleep and circadian rhythms when I was an undergraduate, one of the few things that was quote unquote known at that time about humans and their circadian rhythms that time our sleeping and waking was that we had somehow risen above all of the other species, and that we were not responsive to light from our environment, and that it was social interactions like speaking to each other and so on that synchronized our circadian system to the 24-hour day, and so that we were different than all the other critters on the Earth. And so really, when I was in graduate school, this was sort of the information that was conveyed, and it's hard to explain, as a student when you're studying, how you presume that what you're learning is fact. And so I never even questioned the idea that we were different from all other species and that we were not affected by light. And then I was in the, I was fortunate enough to be selected to make a presentation in Germany of some of our work, and I was in the laboratory that was sort of the mecca for all of the studies on human circadian rhythms, and they had actually discovered that we were not sensitive to light. Anyway, I was in the laboratory on a tour, and the head scientist there was showing us the lab. And I don't know, your graduate students do ask crazy questions. So I'm down in this, it's a special laboratory shielded from external time cues. It was a bunker, deep underground, surrounded by electrical wires to shield electromagnetic influences and so on. And so I'm in this sort of cave-like bunker, and I said to the chief scientist, he's giving a tour of an international group of scientists, and I said, what is it like when it's dark in here? And what a stupid question. When it's dark, there should be, there are no lights. But his answer shocked me. He said, it is dark. And I thought, okay, we're having some miscommunication. Being an ugly American and not speaking German, I just very much more slowly said the same thing but louder. So I said, thinking that somehow, even if he didn't speak English well, he would understand it. So I said, what is it like when it is dark in here? Now, he spoke perfect English. And he said, he also increased his volume, and he said, it is dark in here. And he said, when we say dark, we mean that the overhead lights are out, but obviously we have desk lamps, table lamps, kitchen lights, bathroom lights, and table lamps available to the people. And I was like, oh my God, because the chipmunks and the hamsters and the other critters that had been tested did not have access to, and in fact, studies that had been done in which, like a habit trail type thing, and one side was light and one side was dark, whenever they allowed the animals to self-select their light-dark cycle, they would also not synchronize to the 24-hour day. And so I thought, hold on here. We can't conclude that humans are different than all other species if we have not studied people under the same conditions. So I went back to the lab, and immediately, I didn't check with my advisor, anyway. But he didn't come that often to see the So I started doing a study in which we looked at the impact. So when it was dark, there was no light. I mean, that was, to me, the obvious this. And lo and behold, we could synchronize and entrain people's circadian rhythms. So I went to the scientists. Next year there was a meeting, workshop, and I was all excited to meet the German scientists. And I said, there's some exciting news, when we do these studies. And I expected him to be, thrilled by this finding, but instead he got angry. Didn't talk to me. So this is a hammered site game. I don't know exactly what that means, but I think it's like hitting with a sledgehammer, and you're not allowing any choice to the people. And it's really a social contact anyway, because they're interpreting it as being social. So anyway, didn't want to. It took like 25 years before finally he came up to me and said, I think you were onto something. Anyway, so that's a little background. It hasn't always been recognized that we were affected by light. And really, and the funny thing about the scientific community is, so I'm jumping up and down and saying this, and doing all these experiments, answering all the criticisms, and it took a while. Our work was not getting published, whatever. Anyway, finally, the crazy thing about the scientific community is one day, and it happened sometime in the early 90s or mid 90s. One day it went from no one believing the light could affect people's circadian to everyone recognizing that it did.
The light went on.
The light went on. Somehow, I don't exactly know what happened. But now, simultaneous with all of this scientific debate, there have been massive changes in the environment. So first of all, we have, as the previous speaker said, tremendously increased availability to lighting. And such that it is now normative to have the lights on when it is dark outside. And particularly between dusk and dawn. And increased exposure to light during the day, decreased exposure to light during the daytime simultaneously. So people are spending more time indoors in artificially lit environments. And particularly toxic in the circadian system is irregular timing of our exposure to light and darkness. Because, of course, we evolved in a situation in which there was an incredible metronome-like repetitiveness and regularity to the timing of our exposure to light. And now we have very erratic exposure to light. And so I'm going to be discussing the consequences of this. But let me show you some, scientists are crazy people. Look, this one guy actually spent decades tracking down lighting per capita usage for the last 700 years.
Wow.
13. And I would commend you to look at some of your work, Fouquet and Pearson. 7 centuries of energy services. So, as you know, lighting uses about 20% of all the energy, and he's an economist, and I'm not interested in necessarily the biological aspects. But as the lighting price per megalumen has decreased, so back when you had to kill whales and tallow candles and all this crazy stuff, lighting was very expensive. And as the lighting price has dropped, and this is a log scale, so this is a tenfold drop, tenfold, tenfold, tenfold reduction in lighting price. With each, what he found to be amazing was that with each tenfold decrease in the cost of lighting, there was a tenfold increase in the usage of lighting per capita. So humans basically gobble up whatever kind of lighting. I remember touring Thomas Jefferson's home. He had candelabras all over the table there, and they said it's because he was wealthy, he could afford that much lighting. I even remember in the 50s when I was a kid, my dad, shut off the lights, you know how expensive the electricity is, don't keep a light burning in this room. We don't even think of that. Look at the ceiling, it's just covered with lamps. And in our homes, that's also true. And we didn't even bother to tell the kids this anymore because lighting has come down in the last 50 years so that it's only 1/10 the cost per lumen as it was 50 years ago. And so we are now using 10 times as much per capita as we did when I was growing up. And with LED lighting now, we are going down another 1/10 the cost per lumen. And so we can expect that there is going to be a 10-fold increase in the amount of exposure. And what I'm going to show you, one of the other things that we discovered was that we could reset circadian rhythms and suppress melatonin in totally blind people who have no conscious exposure to light. And that's one of our most controversial findings. We actually submitted to 20 different scientific journals. It took 5 years before the journal finally published it. But it led to the recognition that there's an entirely different biological system that does not involve the rods and the cones, but really uses intrinsically photosensitive ganglion cells to mediate our response to light. And those cells contain the photopigment melanopsin, different than rhodopsin or the conopsins and so on, that is tuned, we inherited it from marine organisms. And it is tuned to the light, the wavelength of light that gets through the ocean. The ocean is blue, the sky is blue, it's on the blue sky, and 480 nanometers of light is the peak light spectrum that gets through to those marine organisms. So that is the photopigment that is in the principally photosensitive ganglion cells that resets our circadian rhythm. And unfortunately, the least expensive LED, the LED lamps, a few years ago the Nobel Prize was awarded to the scientist who could create a blue LED. When I was a kid, when I was in college, we had LEDs, but they were red and green. They could tell you whether the stereo was on or off, but you couldn't make white light with them. The Nobel Prize was awarded because the recognition of how to make a blue LED made it possible to make white light. But it's really not white. It's got those 3 peaks, and the peak from the blue, the blue LEDs are centered at 460 nanometers. So it's very close to the peak sensitivity of the melanopsin photopigment that suppresses melatonin and resets our circadian system. And so now we have a 10-fold reduction in the cost of lighting. We can expect a 10-fold increase in intensity. And it's going to be at a specific wavelength that has the most adverse effect on our circadian system. So fasten your seatbelt. So now here we have a study of Harvard undergraduates. And what I want to draw your attention to, when Will Clark's was doing his undergraduate thesis in the lab, collecting these data. And so he classified people into those who were who had a consistent schedule, and in this case, getting a little more than 8 hours of sleep per night. In this case, a consistent schedule, but getting something like 6.5 hours of sleep a night. And now here, an erratic schedule, getting the same amount of sleep here, either 8.5 or 6.5 hours. But you notice, I mean, look at how erratic this is. This is not, this student is not staying up all night because he's working the night shift. He's staying up all night. He sleeps for like 15 or 20 minutes here. Then he's up until something like noon. Then he sleeps for an hour there. Then he's up till the next day and sleeps for a couple. So he's up for 22 hours here. Then he sleeps for a couple of hours in the afternoon. Then he stays up all night again here, goes to bed about 6 o'clock in the morning, sleeps for 3 hours. And then finally, 5 days later, he finally goes to bed at midnight and wakes up at noon, and then the next day, 4 o'clock in the morning. So
Is he working in a lab?
incredibly irregular schedule. And this one also has a very irregular schedule. So these two individuals, they're not, they're like, okay, I don't have time to sleep, that's why it's such a irregular schedule. But actually, they're not saving, they're not saving any time. Because eventually the Energizer Bunny falls over and, is down for the count for a few hours here. Much more sleep during the daytime here than in the people on the regular schedules. Much more light exposure at night, much less light exposure during the daytime. And we even have some people who are not even on a 24-hour day and are doing what we could sometimes observe in the lab, where they have no concept of the time of day. except this individual does not even recognize that there's any pattern, and that he is exhibiting a non-24-hour schedule that's not even synchronized to the 24-hour day. By the way, I'm sorry, I failed to show you how this is the time of day on the top, midnight, noon, and these are the individual days beneath each other. So when they stack up like this, that's a regular schedule. When they're like this, that means that every day they're going another hour or two later, and they're parading around. And you can see the regular sleepers getting light exposure in the morning, very little light exposure in the evening. The irregular sleepers, very little light exposure in the morning, a lot of it late in the day and during the nighttime hours. So, what are the consequences of all of this electric light exposure between dusk and when we go to bed at night? Well, the first thing is it suppresses the release of the sleep-promoting hormone melatonin. It's a direct suppression of melatonin secretion. And even in our ordinarily well-lit homes, even if we have a regular schedule in which we are in bed between 10 p.m. and 6 a.m., let's just say, or midnight and 8 a.m., in total darkness, as we have in the lab, if you are in artificial light in the evening hours, your secretion of the hormone melatonin is about, the duration of your secretion is about an hour and a half less than it is if you were in dimmer light and less low-rich light. And you might say, okay, what does it make whether you have 10 hours of melatonin secretion or 8.5 hours? Well, large-scale epidemiologic studies, as I'll show you in a moment, reveal that, in fact, the World Health Organization has classified night work as a probable carcinogen. And as you mentioned earlier, and melatonin is both an antioxidant, not only is it a sleep-promoting agent, but it's an antioxidant that also is an oncostatic agent. And it's suppression of melatonin that is thought to be the mechanism by which night work increases our risk of cancer. So the first thing is we notice that we are reducing the duration of our melatonin secretion just by, even if we're on a regular schedule, but we're getting a lot of electric light exposure. And then the second thing is that we have altered the timing of our light exposure. And it's funny, when we were studying this totally blind person in the lab, I mean, bringing him back every so often to assess what time of day it was in his body, we noticed that his melatonin peak was centered at midnight. He was totally blind, going to BC. And so I asked him, now when he was a freshman, because this took so long to get published that we were studying for years, this is when he was a senior, and when he was a freshman, he was like all the other sighted people with the peak of this hormone at 4 o'clock in the morning. So I said, okay, what happened between you? Why have you moved 4 hours early? Everything's the same. He said, well, I do have my own room. I said, okay, tell me more about that. And he said, well, I have my own room. I said, when do you turn out the lights? And he's like, doctor, I'm totally blind. I don't even have any light. He said, the school is too cheap to provide lighting, and I'm not going to buy light. And I said, what if somebody comes over? He said, well, that's their problem. And he said, as a matter of fact, I don't have any shades. I sleep right next to a window, and I don't have any shades on the window. And so then I was looking at his profile and plotting it out this way, and I was reminded of the fact that we call this midnight for a reason. It's actually the middle of the night. I mean, you know, most college students are like midnight, oh, I better check my homework and see if I can do something. But it actually, we have forgotten, we as a society have forgotten that midnight is the middle of the solar night. And so I suspect that looking at this pattern, this is more like the pattern that we might have expected 200 years ago before the introduction of artificial lighting. And nobody did an environmental impact statement to say, okay, if we're going to get all this light exposure in the evening, that's going to shift our circadian system of the average healthy person by about 4 time zones westward. So it's as if we have pushed our biological clock to somewhere between California and Hawaii. And yet we are still trying to get up with the chickens. the largest growing sector of the workforce are jobs that start between 3:30 and 6:30 in the morning. So we've shifted our circadian rhythms late. And then we're trying to get up at the crack of dawn to, staff the Starbucks and to be the screeners at the airport and for the 6 a.m. flights and all these others. We've become more and more of a service economy. Those are the jobs that are opening up. And when one of my former trainees then went to, and I was inspired to think about this study as I was saying in Canton, Washington, Western Massachusetts with my sister.
Chuck, you're dropping your voice.
Sorry.
Speak up. Thank
Sorry.
you.
So I first started thinking about this study after camping on Mount Washington, realizing that you don't start preparing your campsite when it's after dark. You got to get it all ready before it is, and so on. And I was thinking as I was out there, this must have an impact on the circadian system to be camping. And one of my former trainees actually did a study out in Colorado showing that this was with the electric lighting. When they were in school, they were getting much more lighting between sunset and when they would go to bed at night, and their circadian rhythms are shifted to a much later hour than even just after a week of camping. Melatonin onset is earlier, the midpoint of melatonin is closer to midnight, and so in addition to acute melatonin suppression, there is this circadian phase delay, which is what I have been talking about. And we can, so this is sort of a cartoon. This is the phase response curve to light. So we have shown that not only does light exposure synchronize the circadian system, but we can actually reset it. And light exposure before we go to bed at night resets our circadian system to a later hour. Light exposure after we wake up in the morning resets it to an earlier hour. And light exposure in the middle of the afternoon has no resetting effect at all. And the system is much more sensitive than we would have expected. So remember, we started out thinking it didn't have an effect at all. Then we thought if we have tremendously bright light in those experiments, we did 10,000 lux of light, which is the light to which you would be exposed on a clear day in Boston, just after dusk or just before dawn. Much brighter, 100 times brighter than it is in the inside normally. And we got these big phase shifting responses. But then we began to say, well, I wonder what happens if we lower the intensity. And we can lower the intensity 100-fold to the level that we would get much less bright than it is in this room right now. And we still get 50% of the resetting response. And as we began to do more and more studies, we realized, and the same way with melatonin suppression, we can have much less light exposure and still get tremendous suppression of melatonin. And we eventually began to realize that we are just as sensitive as the cockroach in terms of our resetting of our circadian rhythms of light. So first we thought humans had evolved to be a much higher species, and in the 70s this was sort of fit into the notion of human exceptionalism. But it turns out we're just like the other critters in terms of our sensitivity to light. Then the next question is, people are always asking me, well, when I just turn the lights on to go to the bathroom, and surely a short exposure to light does not have much of an effect. So we started out with 6.5 hour exposures, 4 hours and 2.5 hours and an hour and then 12 minutes. And it turns out that we get, even with 12 minutes of light exposure, we get very significant resetting of the circadian system. And now we've actually gone down to even 15 seconds of light exposure. And we can still get significant resetting responses, even to 15 seconds of light exposure. So the human circadian system not only is the duration and the timing and the intensity and the wavelength important, but also the pattern of the light exposure that we get. And so this is a paper that I've been working with Professor Gronauer for many, many years, and he's 94 now. We just published a paper on August 1st together. It's still going strong. I have to go out to Arizona to meet with him. He said, I can't go. But anyway, he has developed a model showing that the resetting responses to light are greatest during the first 15 seconds of light exposure. That they only settle down and reduce the impact a little bit later. So the first 15 seconds of light exposure, you're getting a resetting of 140 minutes per minute of light exposure of your circadian system, and it only it only drops off as you increase the light exposure to many hours. Then you're getting about a half a minute of light exposure, or resetting per minute of light exposure. So that light exposure during the night, and that's why it's so important to have that depleted from blue wavelengths of light if you're going to be getting up so longer wavelengths of light, much longer than 2700 Kelvin. I just came back from a conference in England in which he developed standards for the lighting industry, proposed standards for the lighting industry, working with bodies that set these standards for light exposure during the daytime as well as light exposure at night.
Excuse me, you didn't say that these experiments use full spectrum light or only the blue light that is...
Well, here we go. So here now we're looking at monochromatic exposure. What a great question for this transition to different wavelengths of light. So it turns out that blue enriched light, and this is not just blue enriched, this is monochromatic exposure at 460 nanometers versus the peak of the photopic, our normal visual system. That this blue enriched light, or this blue light, has twice the resetting response as the green. Now it gets really swirly and complicated because at low intensities and for short durations, the green can actually be more responsive than the blue. And you can begin to see this here as you reduce the number of photons and you shorten the exposure. There are some circumstances in which the photopic system, which feeds into this other system, those cells synapse onto these intrinsically photosensitive ganglion cells. And under some circumstances, this can flip, kind of like the yield curves that the economists are always talking about for interest rates. This flips when it goes below a certain intensity. But for all intents and purposes, most of the time we're exposed to so many hours of light that it really is dominated by the blue. And we can show that we can reset the circadian rhythms at all different circadian phases by exposure to blue light. And we've even designed, and they've just installed a year and a half ago on the International Space Station, a whole lighting system that will allow their astronauts to control both the wavelength and the intensity. And this is going to be in the future in their homes. I mean, these are $300,000 per lamp. And so it's not yet ready for prime time. It doesn't have to be these. Don't forget this is the lamp of $7,000 toilets. So, so that ability to control both is I think coming up. And now we can look at the different wavelengths of light. So here you see the campfire. This has much less impact on the circadian system than would be the same number of photons, but in the blue range of the spectrum. Now, another biological consequence of light exposure is actually changing the period of our circadian oscillator in the brain. So we've done experiments in the lab. This is a 73-day study in which we give artificial light exposure in the evening on a system that simulates the Martian day. And we can actually show that following that, there is a change of about 6 minutes in the period of the circadian system after only 2 weeks of exposure to this system. So there's plasticity in the brain. And if we give like that student that I showed you was living on a non-24-hour day, if we give the brain an exposure pattern to light that suggests that that person is on a different planet, the brain begins to adapt to that day length. And then that can create a sleep disorder because they can't easily shift back to a 24-hour day unless they get very specific timing of their exposure to light to bring them in the other direction and shorten the period. And that difference, that 6-minute difference, is about the same as the difference between men and women. Women tend to have a 24-hour, 6-minute day on average. Men have about a 24-hour, 12-minute a day, which is why more men are night owls. There are also genetic differences in period, and that our light exposure can have as much of an impact as even these genetic differences that are associated with sleep disorders. The next consequence is misalignment of circadian phase. So just briefly, reading from an iPad in the evening versus a printed book suppresses your release of melatonin on the nights of exposure very substantially. But even more amazingly, the next day, even if we keep you in candlelight, you can see evidence that the whole system has been shifted over as compared to those who are reading from a printed book the day before. So even when they're not in the light exposure. And this is when we have them in bed between a little after 10 to a little after 6 in total darkness. We now have done a follow-up study from the one that Amber and Chang did, in which they could self-select. They had a fixed wake time for school, but they could self-select when they went to bed. And of course, if they're reading from the light-emitting e-reader, that's what we use to call the iPad, then they choose to go to bed later, even when they have a fixed wake time. And consequently, they're less alert in the morning, even though they're more sleepy, even though so we've shifted their circadian rhythms later. They're more alert at night. They're deciding to go to bed, and they're less alert the following morning. Other than that, it has no impact. That's a joke. All right. Now, just to give you an idea of how important the period of the circadian system is, if this is your regular bedtime, even if you're on a completely regular schedule, going to bed at the same time and waking up at the same time each morning, the period determines when your biological night begins in your body. And so if it's shorter than 24 hours, your biological night may begin at 5 or 6 o'clock in the evening as compared to 9 or 10 o'clock in the evening if you are if you have a period that's longer than 24 hours. And so this can, these people are obviously not going to be the life of the party in the evening. And then during sleep, if they start to release this hormone 5 hours before bedtime, that means they're going to be going to bed and only have 5 hours left in terms of their biological night, much more likely to wake up. Just to give you an idea of how, if you increase light exposure during the day and keep it totally dark at night, you can blunt a lot of these inter-individual differences and keep the circadian system more well in sync with the 24-hour day. Now, people are always asking me, well, how much light does it take to synchronize the circadian system? And we've actually shown that candlelight in most people is sufficient to synchronize the circadian system. So this is 1.5 lux of light. 1 lux of light is the amount of light to which you would be exposed by a candle held a meter from you. This is 1.5 lux of light. And 80% of the people, we did these studies for NASA because it's relatively dim on the space station, 80% of the people could be synchronized to the 24-hour day by candlelight. So it's a far cry from when we started thinking that humans are not sensitive to light. It's a little too much, however, they can't synchronize to the Martian day, so they will need a little more light to keep in sync with the 24.65-hour Martian day. Now, this whole system contributes to sleep deficiency, or these artificial light exposure in the evening contributes to sleep deficiency because the circadian system sends the strongest signal for waking drive just before sunset. And that may be because as a day, and that's true in most day active species. So, and that may be because we have to get our act together before the sun goes down in order to be in a safe place at night. So there's a tremendous surge of waking drive that is driven by this clock in the brain that occurs in the hours right before sunset. But if you have gotten so much artificial light exposure between actual sunset and when you turn on the lights, that you have shifted your circadian system to a later hour, then for you, sunset may be 2 o'clock in the morning that your brain is expecting. And if you have to get up for class or for an exam or whatever, this is why, a quarter of the Harvard students are running to health services saying I have insomnia, because they have shifted their circadian system to a later hour. And that makes it more difficult for them to get the sleep that they need, because this evening wake maintenance zone, instead of being in the afternoon as it was a couple hundred years ago before we got artificial light, all that light exposure that we're getting in the evening pushes that to a later hour, so that it is now at 10 or 11 o'clock in the evening that we're getting that surge. Or if you're a college student, it may be even later. and you may be pushing that wake maintenance zone into the wee hours of the morning. And we've done studies in areas of the world where they still do not have electric light, and shown that they, in the no electricity community, they sleep significantly longer, and their circadian phase is significantly earlier. And finally, we know that artificial light exposure at night can actually stop the internal clock under certain circumstances and completely suppress the release of melatonin so that we don't even have an oscillation. We used to think that we had to go through all sorts of hijinks and it was sort of more of a parlor trick to be able to stop the clock and show that we understood how it worked. And we could drive it to its region of singularity, which is why we got interest in publishing in this in Nature. But now we've shown that just night shift workers, even when gradual advance in the timing of their sleep-wake system, and then we look at them the next day, many of them, their melatonin rhythm is completely flattened like that. That is about 20% of the workers. And this may be that group that's particularly susceptible to the increased risk of prostate cancer and breast cancer and other endocrine-related cancers in that group. But you can see that on average, the group, just by having done that for a few days, has a much lower melatonin level on the constant routine, which is not when they're working the night shift, but they're simply, we're assessing it after that is finished. So it's not shocking that this is all associated with increased risk of various disorders. So sleep disorders are much more common, commonly related to difficulty falling asleep, difficulty waking up in the morning for those with delayed sleep phase disorder. Insomnia, a substantial fraction, about 1 out of 5 insomnia patients have a misalignment of circadian rhythms that is causing the insomnia. We know that there are adverse metabolic consequences. Those who sleep on their days off is much different than the timing of their sleep on their work days, so-called social jet lag. They have a higher risk of being overweight and obese. And even sleeping at night with artificial light, and this was just published in June of this year, increases substantially the risk of obesity in women. And it's a prospective study. They studied these women, meaning that their use of artificial light at night was recorded almost 6 years before the outcomes were recorded. So it's not like you ask them after the fact. This is 43,000 women who were studied. And they had no history of cancer and all these other problems. And then you see that their risk of becoming overweight and obese during that period was substantially increased. And so a body mass index increase of 10% or more, there was a 13% greater risk. The incidence of being overweight was increased by about 22% just for having a nightlight in your room during darkness, while you're sleeping. And the risk of new obesity during this 5.7-year period was about 33% higher in those who had light on at night as opposed to. It's amazing how many people say, I can't sleep without the lights on. TV's on, and because we have now created this whole environment in which people have the expectation of, and so having instead motion-activated lights that people can know that if they sort of wave their hand, because some people are afraid of the dark, if you can assure them that they will be able to get the lights on, they will know if somebody comes into the room because the lights will go on and so on. You can sometimes get people off of this. It has adverse outcomes in hospital patients. So in these neonatal intensive care units, this is a study of 5,000 children, if they simply cover them so that they're not continuously exposed to light at night for 12 hours a day, they gain more weight, dramatically more weight over the course. Their pulse oximetry, which is a measure of their health, is dramatically improved. And it's so much better that they actually discharged from the hospital more than 15 days earlier than if they're in continuous light. And yet, we still have people that are building brand new intensive care units. $1 billion in the University of Colorado, and they still have continuous light. It makes me insane. Because it's very hard to get this message across. And we're doing some new studies because it turns out that nobody's understood why spontaneous births happen more at night. It turns out the uterus, near the end of pregnancy, becomes covered with melatonin receptors. And much to the irritation of the obstetricians. And when melatonin is released, the uterine contractility becomes much higher. And we've now shown that with exposure to artificial light, we can actually reduce those contractions. So it may be making it more difficult. Now we're using more drugs to get because we're not letting the natural endogenous release, and women release twice as much melatonin as men do at night, maybe related to this. But of course, if we suppress it by keeping them in a room that's totally lit, and we're like, okay, are you ready to get pregnant? Then they have to be induced. Now, the immune system is also adversely affected if you just shift the timing of the light-dark cycle. By 6 hours every week, you can dramatically increase the susceptibility of animals to immune challenges, adverse effects on cardiovascular risk. In those students with the irregular schedules that I showed you at the beginning, their circadian rhythms are shifted 3 hours later. Even I told you the average person is shifted 4 hours later than they were before artificial light. If you have an irregular light exposure pattern, you're going to be 3 hours further than that. So now they're 7 hours later. So basically, they're on California time. They're on Stanford time, but they're trying to go to school in Oregon. So that means that if they have a class at 9 o'clock in the morning, it's 6 a.m. biological time when the exam or class is happening. The 8 a.m. exam is going to be 5 a.m. biological time. So it's not a shock that they don't do as well academically with their schedules. This is the relationship between regularity and their academic performance is very highly significant. And the economic costs of sleep deficiency are staggering in terms of increased occupational injuries, absenteeism, presenteeism, motor vehicle crashes, industrial accidents, and costs hundreds of millions of dollars. So I think we really need a specialty focused on this, and that's why we're spending so much effort on a sleep matters initiative at the Great to try to bring this message out there. But it's a difficult one, and nobody wants to turn the phone. But I commend this group because I think it's such an important message to get out. Thank you for the opportunity.
Now you can see why my colleague, Professor Mary Harrington at Smith, said, James, you just hit the jackpot. In getting the good fortune to have Chuck Czeisler come address today. We're over time, but let's just take advantage of Dr. Czeisler's presence to take a few questions if you would.
Sure.
Yeah, great. So Mike and then
Do
Russell.
things like oral melatonin supplements at bedtime assist with these problems? Or
Yeah,
is it
so
just
they
unhelpful?
can. It's difficult to get pharmaceutical grade melatonin, much of the stuff, because it's not regulated by the FDA anymore than they regulate containers. They don't check the purity or anything. There are a couple of outfits that have, one of them is in Sudbury, Massachusetts. There's a company called Pure Encapsulations.
Say it again?
Pure